Yeah, this talk is hidden power of HTMLBars because that's what's on the poster, so that's what everyone was expecting, and I know no one wants surprises. But what it really is scope in Ember.js templates. We're actually not going to talk about HTMLBars that much proper. We're really just going to talk about Ember templates, how they work, how you access variables in them, and how there are some corollaries to real programming languages, and how they deal with variables as well. Again, Mixonic is my handle, Matthew Beale. I'm on the Ember.js core team and work with these consultants at 201 Created. We work in New York on Ember apps, and we like to do a lot of work on open source projects and working with companies on how they can best use open source. I've only been here for a few days, but I've noticed a handful of differences. I am from Brooklyn. I live in Brooklyn, New York. And in London, this is what I presume everyone looks like when they say cheerio. They have like a nice smile. And in Brooklyn, if someone were to say hello with cheerio, it'd be a little bit more scary at that size. You have this great tower, Big Ben, which is elegant and delightful. And this is the Big Ben in Brooklyn at my bodega. He's also delightful and insists on it. But most interesting has been what these are. So these things are called chips in London, and they're called fries, of course, in Brooklyn. Thick fried potatoes. Jamie confirmed this for me. And then after doing more research, realized that we have crisps and chips as well. I couldn't help but notice like this kind of corollary going on, that these are all potato products. So I was thinking, what if we could extend the system? We have these fries in London, but like, what if we didn't want to call them fries because we already have fries in the US. So if we just call them crisps, then we can get this like grand unified theory of fried potato products. The London one, of course, being metric, and the US one being freedom. Slight hints of Godfrey's talk from EmberCamp. If you haven't seen it, you should go watch it. But really, like, how do I map these things, right? I'm in like some bar, and someone says, "Hey, look at those chips," and I need to figure out like, what do they mean? It's really important for me to know what fried potato product. And the answer, of course, is that I check the temperature of their beer. And if the beer is warm, then I know that they must be like fries, and if not, then I know that they must be chips. So what do we call this fact, this piece of information about the temperature of the beer that let me solve the problem of what these are called? Well, we're going to call it scope. We're going to call it a piece of information that was in the scope. So we had a scope of a conversation. I'm in a bar, there's beer on the table, and there's fries or something like that. And all this information is in one space where I can access it, and it kind of influences other pieces of information and tells me what it means. So given that scope and a couple of rules that I've internalized about like the temperature of the beer and such, I can go ahead and know that cold beer, they're in NYC, so chips, so I'm going to have thin, flat slices. So I can get to what the actual like entity, what the real thing is that I want to actually bite into. So how do we do this in Ember templates, right? This is an Ember.js template, and we can see that it also has like, a bunch of labels. We have names, we have some snacks, and we have like packet.name and packet.price. How do we know what these things mean? I mean, most of you know what everyone knows what these things would probably mean, right? Yeah, in Ember? Yeah. We have some scopes as well. The scopes are really easy. Every template in Ember 2 is just one scope. There's one there's one spot where things are looked up. It doesn't change. There's a shadow arrow because we kind of have something added to our scope. We have a new local variable called packet that we have to worry about. But those two things are pretty simple. But what are the rules? Right? The rules aren't actually there in the code. We don't see them. They're in code somewhere. Someone had to write the code to codify the rules, probably Yehuda. But the rules are mostly like in your brain as you develop. As you write the code, you have like internalized these concepts. And there are kind of two ways that you could resolve those different values in that scope and decide what they're going to mean. The first dynamic scope is how programming languages started to have variables back in the 1960s. It's still used a little bit. We're going to maybe bring up how it's used in JavaScript, not that much. But really, lexical and static scope is far more common now, and it's what you're probably used to, even if you don't really know what lexical static scope means. And the fact that they're lexical and static is kind of an interchangeable term for this use. So let's look at dynamic scope. Dynamic scope, the name resolution depends on the program state. It depends on the execution context or the calling context. So if I have a set of functions that are being called, if I call function A and that changes the value of a variable, and then I call function B. B sees that new value that I changed in A, because it was called like on top of it in the stack. And we can demonstrate this with some Perl. Who knows Perl? I'm sorry. So Perl is a great example for this because Perl gives you every way to do everything that you want to do, and it supports both at the same time. So this version in Perl is written using dynamic scope. We use the local call on line 8 there to set the name fry. So this is what actually gets printed out when you run these. So you say name, it's going to kick out crisp, then the second one is going to kick out fry, and the last one is going to kick out crisp again. When we do name, this is going to be really simple, right? It's just crisp. It's very simple to read. When we do the local sub down here, what happens? So we call this function. It's going to set the local of name fry. And now we call show name. There's no arguments, right? We access name, and what comes out is fry. Because the execution context, the context of that function being run, was changed. And then the last one, show name, we access name, and it comes back with crisp again. And that's because we're outside of local scope. Now that function ended. And so that value that we set is like popped off and thrown away. And it goes back to whatever the value was before. So when you're reading this code, say you're looking at show name here, you're looking at this guy. What does it mean if you're just staring at that in isolation? Remember that local sub could be in like any file anywhere, right? It doesn't need to be in this file. So the value of this thing could be changing at any spot in the code. The tricky bit about this down here is that it means that you really need to understand, in order to know what name is, you need to understand every context that that thing could possibly be called in. And that's a big list in a large application. It's going to be very difficult for you to reason about. The second system is lexical static scoping, again, interchangeable, and something you're going to be a little bit more familiar with. This one, note that it's based on the lexical context. And so lexical context really means like as you read it. It's in the structure of the code itself. It's not something that's about runtime. It's something that you can actually infer by looking back through the source code. And in this case, we're going to kick out crisp, crisp, and crisp, because in my sub, we call my name instead of local names. So now it's going to be using static variables instead of using dynamic variables, because Perl allows both. So this one's static, so it just sets fry. It's only available in that one context. When we call show name, we've never passed that variable into it. We haven't made it available in the lexical scope, and so you get name. And this is kind of what you'd expect from JavaScript or most languages that you've probably worked in. If we want to get that information into show name, we would need to pass an argument. There's really no other way to do that. And what that does is it makes it very clear when you're reading show name, what could I be printing out? I know I have to be printing an argument that someone's passed in, so I look for people who are calling me with arguments, or I know I have to have like this variable, which is in my scope. What's my scope? It's this file, so line 5 is the only thing that could possibly be name. And it depends on the location in the source code. And this has a lot of benefits for us. Much easier to optimize. It's going to be much easier for developers to read and work with, partially just because they're a lot more used to it, and partially because you don't need to understand all of the execution context in your entire program to understand what that variable means. So we can look at how Ember used to handle these concepts. In Ember 1, if we have this template, like what does name mean? It's pretty tricky, right? I mean, it could be anything. You could have like object proxies in there. You could have like maybe there is an item controller that's on the view when it's in there. Like anything could be happening here at all. It's very difficult to reason about what that is. And I think that's akin to dynamic scope, right? Something has an execution context that's changed what this variable is going to mean for you at this moment. But it's very difficult for you to know as a developer, if you open this up for the first time, what is even changing it in the first place. So in Ember 2, we've kind of tried to ease people toward this new template style. And one of the big benefits to this is that we know kind of like there's far fewer things that this could be, or that name could be up above. We know that name is being read directly off a model. We know that this comes directly off of packet, so we just need to look at what packet is. I've crossed off helper because technically this could be a helper with packet.name, but never name your helper with a dot. You'll be a bad person. And that's something that we want to try and fix, is the conflict of helpers, because that's kind of the last thing that's stepping on things in the namespace. Great. This also has a distinct corollary to JavaScript, right? This is static scoping. JavaScript has static scoping. So this is very easy to understand. If you've been able to assemble a string, then you should be able to understand what this template does. There's no more magic wizardry of what name could possibly mean at any given moment. And it's worth calling out that this is like an intentional thing. This is not something that happened as like a side effect of other work or that we're coming back to after the fact. This is something that React gets natively because it's based on JavaScript, and their templates are interspersed with the JavaScript, so they naturally get the facets of JavaScript, which are static scoping. Trying to emulate that was definitely part of this goal. And also, as we begin to take performance more and more seriously, begin to realize that it's easier to implement the performance for a static system than for the dynamic system. And so Glimmer itself, like at a very low level, has these concepts as part of it. So before we run into the next section here, I just want to talk about understanding concepts like composition in component composition, in the way that we use components or like use actions or use a given feature of Ember. All that stuff is really based on understanding how templates deal with variables. And I think that's kind of the spot that people don't dive into when they want to understand how to do component composition. Instead, they want to know like how they can pass components to each other or something. The more important thing is to understand truly how scope works in Glimmer and in HTMLBars. And from there, all of those other things kind of fall out of it naturally. So for instance, let's take like closures. Closures are a tool that you can use inside of JavaScript, right? They're just like a tool that you're used to. Closures mean that to use closures, your language has to support first-class functions, which means you can pass functions around. We can return a function on line 3. You can pass functions to other functions. All those things mean that you have the ability to do closures in your language. So in this example, we're creating a closure, which is line 3, and it's a closure because it closes over the local value of name. So name is in that scope. Now it accesses name. Now on line 10, despite the fact that name is not in our scope really at all, we can still access that variable through the closure. And Ember, of course, has something similar with actions. In actions in Ember, you can go ahead and create this object, which is your action. This one takes alert, which is the name of the action, in one argument, turns it into one object, one function that can be called, and then passes it down. And when you click on line 2, then it would execute that function for you with the action. That's a very poor example because it uses with, and that's very boring because everything's already in the same context, right? So why bother with this currying with the closures? This is a far better example because we actually are yielding. So we have one scope for generate say name, and we're going to pluck the name out of that scope, and then we're going to yield in a function on line 2, and then we can use that function wherever we want to access that variable. We don't need to access name itself. In 2.3, we hope to introduce this hash helper, and you can use that excellent polyfill that we talked about this morning. And this kind of allows you to yield multiple actions, right? And then to also to yield multiple actions and kind of design like an API around these, which is a technique that I really like using now for add-ons and such, and documenting, oh, okay, I have an object, it's yielded in called UX or called names or something like that. And now you can call names.say British or names.say American if you want to access it. And again, that's just based on closures, right? There's nothing that's special about this technique. This is just a technique that you would have in any static variable language, anything that has functions as a first-class object. A little bit more new, and you can use this in master today. It's not even, well, it's still behind a feature flag, but that feature flag is enabled by default. So if you just pull down Canary, you can try to use this new tool. We have a component thing that creates a closure out of a component itself. So up on line 3, we say component. I'm taking the name of that, and I'm taking the argument of name that's actually passed in. We're going to create one object out of it called say British. And now anytime I have a dot in my path, I know that this thing might be a component. And so we check, oh, hey, is it a component? If it is, allow it to be rendered and treat it like a normal component. So we can create really rich APIs out of these, again, just using those same like core component concepts. Important about this is that we think the most important use case for these is really add-ons. You can imagine form 4. If you've used Rails a lot before, you have form 4 do f, and then you can access f.input and f.submit and things like that. That kind of API is definitely enabled by these, and it kind of lets you take private things and expose them, and we're going to show how that interacts with new features that we're looking at later on. So pods, local lookup, and closures are 3 concepts that are going to come into the same space here and interact. These are two URLs that kind of go over what the current proposals are for local lookup. There's not really an RFC or anything like that right now. And Robert has also given a talk in Austin a week ago, that went over a lot of the concepts. So I suggest you guys check those out if you want to learn more about the pods and local lookup stuff that we're about to run through. But importantly, pods and local lookup bring in something that we haven't had so far in any of the discussions that we have, which is like the concept of modules, like namespaces, where we can have private things that we don't want to share with the rest of the world. So given that this is my application here, in my index template, I'm going to go ahead and call the same generate save name as UX, and it calls this say British. So we call generate say name. Generate say name, of course, loads that template. So let's pop open that template. We have generate say name. It's going to create these two closures over say button name and say button name with chip, with crisp and then chip, two different arguments, two different values that they're closing over. Say button name is not in our tree, so where should we put it? Like, where should we create this thing if we want to implement this functionality? Today in Ember, you'd go ahead and you would just add it in your components directory, right? And the downside of this is that if say name button maybe is something that you're not really don't want to document, you don't want people in the outside world to use, it's not part of your public API surface, you don't want to have to maintain it and have backwards compatibility with it. It's like an internal tool. In the concept of pods and local lookups, you can basically nest another components directory under any arbitrary thing in the tree. And then those things become locally discoverable by your template, but not by templates in any other parts in the code. So say button name here can reference the say button name over there, but for instance, from my templates file in index, that would not be able to access say name button. So I have like a private thing, and I'm using this closure structure in order to turn it into a function that I can then pass to other parts of my UI builder, my template system. So the say name button, is this the say name button? Oh, say name button might have gotten lost in there. No, did it? Yeah, okay. So basically this guy here, let's go back to this. We're going to yield, right? So our yielding means that we come back here and now we're going to look at this block in the middle of this whole thing. We're going to execute line 3. Line 3 is going to render say British. So say British was our closure. So now we can actually execute that. We go to that template and we can use that template. It uses name, so it's closing over that value as well. So that the state of name was shared in between the generate say name and in between say name button. But that state was just between those two things. It wasn't anything that the index template had to know about. And then we go and we yield here. And notice that name is not in here at all, right? Name was totally internal. It was just passed in between those two components. And that's a really great way to have private communication channels that you don't want to make public API. And again, these are URLs, because I thought people might be more excited after seeing local lookup than they were before they saw it. Go figure. So another concept is partial application. And partial application is kind of similar to the term currying, where you take arguments. And but currying is a very specific, as I learned as I looked at this, currying is a very specific kind of technique that's about boiling things down into a function that's called with one argument. And that's not really what we're talking about. There's another term called partial application that we're using here. Partial application is about creating a function that basically has some bindings already passed to it. So you close over some things from scope A, but then when you are invoked, you pass other things, and you want to combine those things when you're executed. And this is something that we're also able to do. So this is an example in JavaScript, way simpler than it sounded, right? Up here we have a name. So this is our first scope where we're going to close over that thing and use it on line 4. And we return a function on line 3 that has an argument. And then down here we actually pass in Mr. And so we get Mr. Chips out of this guy. And that's that's all that partial application is. It's a big, large set of words for a very, very simple set of concepts. And this is an example of how we do that with actions in Ember. You yield out alert and crisps. So we have the name up there. And then down here we have the honorific that we're passing at invocation time. So we have one thing that we curried over and one thing that we have at invocation time, or closed over, one at invocation time. And if we have our action, it would just look like name in honorific, because that's the order that we have here. Name was the first thing that we create a closure over, and then this was the next thing that was passed. So we get name and honorific, and then we can log those out. this would be an example of doing the same thing with components, because components work the same way with the new component helper, right? It's a function that builds part of your UI, helps build the tree of your DOM. So up here we've created two closure components that have an honorific for each one that's different. They're MPs in Britain, and they're going to be reps in the US. On our button, we just invoke it with the name in the honorific, and then we click say the name. And down here, we're doing this first one, we're passing name. And remember, the thing that was closed over was the honorific. So we have one thing here that we are doing at invocation time, and one that was decided when we created the closure. And then here we're actually doing two things. We're going to use one thing that's local, and then the second item honorific here, we're replacing the value that we closed over before. So we're overriding the value that previously was set. So these are really powerful tools, and again, we hope that people can use them to great effect for, especially for add-on APIs. So the last thing that I want to look at here is like, how far could you take this, right? If we just have functions and you just have, you have functions and you have like static state, then what kinds of other weird things that we can do? Is Sarab here? Sarab, where are you? Where are you? He's here somewhere. He's hiding. Yeah, he's here somewhere. I don't know where he is. Sarab worked on this, worked on a lot of this code with me, and he told me that he gave me a use case at some point. We were talking about some other bug, and he described the use case that he had for this feature. And it turns out that his use case, where's my thing here? It turns out that his use case was to have recursion, which was really striking. So over here, we create a closure component, right? Component with recurse list, and we query over a label of color. And then we invoke that component by passing in the closure component to the component helper, because we don't have a dot in the name, so we need to pass it to the component helper. And then we pass in the component to itself, the closure component again, passed as component to itself, and we pass in the list. Down in our component down here, first we just kick off the first object and log it. So there's our color red is the first value off of our array that we have over from the routes. And then we do with tail list. Tail is a helper that I wrote that throws away the first thing and keeps the rest of the list. And we go ahead and invoke with that list passed to ourself again. And we do that as long as there is actually a list. So this allows us to take the array and render it as a recursive list of components, which is kind of awesome. You could render arbitrary data structures like recursing down an object or something like that instead of just over an array, which is kind of neat. But this is just another technique that we have in the toolbox now. Not that I would necessarily recommend that you go writing recursive components all over your UIs. Yeah, so Ember templates have these really strong scoping and consistency rules that come from real languages like JavaScript. They should be concepts, and they should be like patterns that you're already familiar with. I really suggest that you think about the lessons that you learned mastering JavaScript as you worked learning Ember and writing Ember applications, and try and apply those same patterns around how you would use a closure and what like a well-designed surface is like and how objects can talk to each other, and try and apply those lessons into Ember templates, because they now have a solid enough foundation that a lot of those concepts just work smoothly, and you don't need to rely on like specialized hacks like finding the nearest view and things like that. We have a lot of really powerful composition and scoping tools. And that's pretty much it.